Okay, this is part 2 of graphing using a table notes. We just finished this example and now we're going to go on to the next page. We're going to skip example 2 for right now. We're going to go on to the next page and we're going to do this example up at the top. And you're going to not look at that answer over there. Okay, so in this problem, y is already by itself. It's in slope-intercept form. And I'm going to just show you a different way to show your work for this equation. It's using a table, and my first column is my x column. Those are going to be the numbers I'm going to pick to plug in for x. My second column is my work column, and so I'm going to leave a little bit of room here to get some work in. My third column will be the y, and then I'm going to write x comma y in my fourth column. So this would be another way to show your work for the tables. I'm going to pick -2 to 2. You get to pick any numbers you want when you're making a table. And sometimes when you're dividing by 2 or something, you would want to pick only even numbers. Maybe you don't want to pick negative numbers. They don't fit on your graph. There's lots of options you have for picking those values. And you're going to want to pick wisely when you get to the next assignment. But for right now, I'm going to go -2 to 2. So I plug in those numbers, 2 times -2 minus 1, and you can make it plus -1 if you would prefer. So 2 times -2 is -4, plus -1 is -5. So that goes in the third column, and my point is -2, -5. And then I'm going to continue that in my table. So 2 times -1 plus -1 is -2 plus -1, which is -3. 2 times 0 plus -1 is just 0 plus -1, which is -1. 2 times 1. So 2 plus -1 will give me a 1, so that's 1, 1. And 2 times 2 plus -1. Now we want to pick 5 values, at least 4, but usually 5. 4 there. Because that way, if we make a mistake in our math, we'll notice when we draw our line or our points, we plot them, they don't make a straight line. That would be a problem. All right, so now we're going to plot these out. So it's -2, -5, -1, -3, 0, -1, 1, 1, and 2, 3. So they are all in a nice straight line. So I'm going to use my ruler and connect them. Like I said, if one of them was off to the side, you wouldn't realize that you made a mistake because the other ones would show you that where the line was supposed to be so you could catch yourself. And then when I'm done, I just wanted to make some observations right now. So I'm noticing that this line goes up from left to right, and it's pretty steep. Our determining factor for steepness is a 45-degree angle. So this would be a 45-degree angle, and that's steeper than that. So that I would consider that steep. This would be not steep, an angle that was less than 45. And I also want to say that it crosses at y equals -1. We're always observing where it crosses the y-axis. We don't really care where it's crossing the x-axis. So you can kind of look at these trends and then look at the equation up there and see if you notice anything. All right, so right now you should pause the video and you should do example 3, skipping example 2 and doing example 3. And then I'm going to show you the final result. So when you're done, then you should be able to check with your answer here. Okay, so the answer to number 3, you should have just done all of your work off to the side. It's steep, it's going down, it crosses at 1, and I made a little note that said careful with your numbering there. It's a little hard to see my coordinates, so I'll read them to you. It's -2, 9, -1, 5, 0, 1, 1, -3, and 2, -7. All right, so now we're going to go back to the example that we skipped a minute ago. So let's go back to example 2 on the previous page. Example 2 is a little different than the ones that we've been looking at because there's no slope-intercept form. There's things that are missing here. One of these graphs just says y equals -3, and the other one that they want us to graph is x equals 2. Well, these are special lines. So first let's focus on y equals -3. And it says regardless of the value of x, the value of y is always going to be -3. They're telling you right now y is always -3. X could be 1, x could be 5, x could be 1,000,000, y is going to be 3. So the graph of this is a horizontal line, and it's going to be 3 units below the x-axis. Okay, it's a horizontal line 3 units below the x-axis. So that would be right here. So y is -3 here, y is -3, y is -3, -3, -3, -3, all along there, going on forever and ever and ever. So the graph, when y is equal to a constant, is a horizontal line right wherever that number was. Y equals -3. Okay, now if they give you one that says x equals a constant, like x equals 2, then it would be a vertical line. Okay, the value of x is always 2, regardless of whatever that is. The graph of x equals 2 is a vertical line, and it's 2 units right of the y-axis. So here's x equals 2, 2, 2, 2. See, x equals 2 in all those spots. So I can make a nice line through there with my arrows because it's going to go on forever. And that is x equals 2. Okay, so now go to page 9, pause the video, and do those extra 2 examples. Number 2 and number 4, the ones that we skipped. And then I'm going to show you the answers. Okay, so here's number 2. It's at x equals a half. It's a vertical line. And here's number 4. It's y equals a -1.5. And there's the graphs. So just to kind of fill in our notes from what we just did, the graph of y equals b, so y equals a number, is a horizontal line. And it's always going to pass through the point 0 and whatever that number is, so 0b. If it's x equals a constant, it's a vertical line, and it's always going to pass through that number and 0, that point on the x-axis. And I just wanted to point out that these are not a function. Okay, the one that are a vertical line, because they would not pass the vertical line test. Remember that vertical line test? So this is a function, this one down here is a function, but look at this guy. Every number hits right there at the same time, so that's not a function. All right, so let's flip the page. We have our last example. I know these notes are long, but this is kind of the stepping stone for all of the rest of the unit. So what they would give you sometimes is they would give you a function, and then they would say, I'm limiting your domain. So they're telling us that the domain can only be 0 or greater. So they started by making a table, and then what we would do to each number is we would multiply it by 2 and then add 2. So to fill in the table here, since my notes are getting kind of long, you can do the math off to the side and pause the video if you would like. Here's my work. So my points are 0, 2, 1, 4, 2, 6, 3, 8, and 4, 10. Okay? So I'm going to fill those in. You know that I did the work. Notice I have a pattern again. And then we plot the points. And when we plot the points, we start at 0 and make our first point, and then go up from there, 1, 4, 2, 6, 3, 8, 4, 10. And when we draw our line, it can only go up and to the right. I don't have an arrow going to the left. Okay? So we connect the points with a ray. That's called a ray when it goes in one direction because the domain is restricted. They told me I could only be equal to or greater than 0. Now, we have to identify the range. So what do you notice about the y values? The smallest y value is what number? It's 2. So you can, from the graph, you can see that all points have a y coordinate of 2 or more. So my range would be y is greater than or equal to 2. All right, go ahead and pause the video, do the example at the bottom, and then I'm going to show it to you. Okay, here's that graph. The range is y is less than or equal to 4. It starts on the y-axis and goes down to the right. There's my table of values. You can pause the video if you need a little more time. And this is the end of the notes. So see Mrs. Wyman if you have a question. And you're going to continue on to the next page.